Hi, everyone. Welcome to our April event. We are glad you're here with us this afternoon, or afternoon if you're in the UK. We are going to be dealing with a big topic today, presented by Clayton, who's part of the OSL team. So I'll hand over to him in a minute. We have got time for questions at the end. So if you just want to write them on the side, we'll deal with them at the end of the session. And just to remind you, we have events every month. The next one's on the 25th of May. So put that in your diaries. And without further ado, I'll hand over to you, Clayton.
Have a chance to present to you again and talk a little bit more about the sort of wider work that, the context of WikiHouse, which I think we sort of wanted to answer our own questions about the relevance and importance of what the work we're doing and how that fits in the sort of broader context and this broader global challenge that we're facing. So I'll just sort of dive into it. Excuse me, I've got a bit of a cold at the minute, so if I sound a bit croaky, I'll just share my screen quickly. All right. So just a sort of general introduction for those who really aren't familiar. WikiHouse is part of an organization called Open Systems Lab. We're a non-profit R&D lab, and we sort of collectively look at design issues around the built environment, and particularly sort of the operating systems of how the built environment is formed and reformed and created. And as part of this presentation, I wanted to also give a big shout out to Alistair Parfin, who's sort of taken and remixed versions of this, and then I've remixed his version. So it's constantly evolving, and hopefully starts to sort of cover the some of these important aspects related to the work we're doing. So part of it is obviously if you come through this through WikiHouse, you already know quite well the context of WikiHouse, which is a construction system. So that's one of the projects that we do, which is working on how do you make zero carbon construction more accessible, easier to do. Some of the other projects that we're dealing with look at design and procurement systems. So this is part of the project which we call BuildX, which is looking at how do you make design itself more accessible to people. And particularly the whole process going from a concept to sort of finished building is really opaque for most people who aren't construction professionals. So we're trying to smooth that process, make it easier to understand using digital tools. Then we're looking at the planning system, working with local councils to digitize their planning regulations and build interfaces for that for both planners who are writing the policies and also the end users who are wanting to build something and need to know where to start in terms of what they can build, what permissions they're allowed, and how they go through that process of applying for those permissions. So that's definitely ongoing and being tested with numerous councils in a minute. And then one of the things we started to get more interested in, when I say starting, we've been doing this for years, but starting to sort of formalize is work on the property system through a project called Fairhold, which I'll sort of touch on in this presentation. So I'm going to dive into the big picture here, which is the sort of overarching question that we all want to know is how exactly are we going to achieve zero carbon? It's talked about, but is there a plan? How are we going to get there? What needs to be done? And for this talk, I'm going to sort of focus on the context of the UK. And obviously, this is a global issue, and we all share the same atmosphere. So we do need a global effort, but the UK is obviously the case study that we sort of most familiar with, but also is one of the sort of high carbon emitters per capita. And the sort of big issues that come from this, of course, we know the face of climate change and the climate emergency and the sort of urgency of what we need to do, and we also understand that behind all this, the problem is the sort of systems that we build our economy and our lifestyle and everything on is sort of baking in these emissions and this trajectory. And the only way we're going to change that is by looking at the models. And I think one of the things I quite like about this is that there's a lot of these invisible systems that we just take for granted. And one of the first things that we can do is recognize that they have been designed and they have been created, and then equally so we can create a better alternative. So yeah, we're very fans of that quote. And so when you look at the sort of plan for the UK, we, as a nation, signed on to a legally binding agreement to reduce emissions by at least 100% by 1990 levels by 2050. So it doesn't give us a lot of time left, 27 years. And other countries have similar targets. So exactly how we're going to do that? What's the plan? And fortunately, there is something of a plan, at least a roadmap. And the UK Green Building Council put this roadmap out in 2021. It's a really comprehensive look at the sort of path to emissions reduction for the built environment. Definitely well worth a read if you're into this kind of stuff, because it looks across all built environment sectors, actually all sectors in the UK. And so you start to look into the details here of the data. You can see that it's more, the built environment makes up a huge proportion relatively of UK's greenhouse gas emissions, as much as 42%. That includes infrastructure, buildings, both embodied carbon and emissions. But that's a huge problem to solve. And as built environment professionals or people interested in even building their own homes, there seems to be a sort of low-hanging fruit that we can tackle using our expertise. So, and then if you sort of dive deeper into it, particularly the just based on emissions profile itself, you get sort of up to 25%. So I'll sort of pull these numbers out in a little bit more detail. So the this sort of third of it is transport emissions, and then we have a breakdown of operational emissions, so both from domestic buildings and non-domestic buildings, and then also the emissions from the embodied emissions of new construction and new materials, both domestic and non-domestic. And there's a bit left over, which is infrastructure and emissions from like refrigeration, which is a notable percentage, but not kind of what I'm focusing on here. And so I think it's important to ask, the big question is how are we doing so far on this? So if you sort of look at what's been achieved over the last sort of decade or so within the UK, there's been a massive surge in decarbonisation of the energy system, and that's primarily driven by offshore wind as a big play, and solar to some extent. But we're doing sort of less good on things like residential housing and agriculture, and so notable improvements on other things. Transport is expected to sort of start to trend down, but the residential sector is a really interesting test case, and that's something that I want to look at in a bit more detail here. So jumping back then, in terms of carbon emissions, so this is operational emissions for both houses, domestic buildings and non-domestic buildings. If you look at where we are with existing buildings, these are based on EPC ratings, so sort of energy performance ratings for UK dwellings, and generally pretty poor, the UK housing stock, especially relative to European standards for the existing housing. That's legacy of leftover Victorian and pre-Victorian residential construction, but even more the recent stuff has been really poor performing, and so we've got a big task to see how do we get that, improve that, and push that into at least C, if not B, A levels of rating. And with new dwellings, okay, it's great we're building to those performance standards, but is that enough? Is that something that we're still going to have to retrofit later on down the line? And then based on that, obviously the big point to pick up here is that most homes that have already been built, there will be an increase by 2050, but a large proportion of it is going to have to be existing buildings that are already poor performing that we need to retrofit. And then we obviously need to make sure that anything that we build new is built to the highest possible standards. so that it isn't going to involve extra work to try and get it to a point of zero carbon going forward. And and the Green Building Council roadmap looks something like this, where you can see where we're currently at, and there is a good downward trend, but there's a lot of work to go until we get to officially sort of net zero carbon. And a lot of that's going to come from the operational carbon of both domestic and non-domestic buildings. So on that note, how do we make retrofit easier for everyone? And also the knowledge systems around it. It's not just a case of in terms of design exercise and the available materials and the sort of solutions for achieving retrofit. There's also going to be immense work in terms of supply chains and workforce and the skills needed to do that. And retrofit can also mean it's not just about retrofitting residential buildings, but also can mean change of ownerships from commercial, derelict commercial space into really high quality residential housing. And when you start to look at the scale of the task ahead, then you start to run into the sort of cost that this is going to bear on the UK economy, and just the immense challenge that's going to take to be able to sort of to do that. And it's not insurmountable, but it's going to take a lot of political will and to do so. But at the same time, there's a lot that can be done in terms of the base level of understanding and accessibility to new technologies and new solutions, and the knowledge around that. And so one of the things that is changing is this push towards electrification of housing, and some policy is helping this in this space. Obviously, the outlawing of gas boilers will push us more towards electrical heat pumps, MVHR ventilation systems, where you've got buildings that are built to a high level of air tightness, and just in terms of indoor air quality and comfort, and heat saving. Heat pumps make a lot of MVHR makes a lot of sense. We're already seeing sort of a large uptake in rooftop solar for domestic buildings, and hopefully that will increase. And then it also means switching appliances as well. Anything that is about burning fossil fuels, in the case of stovetops, gas, can be replaced with electrical systems like induction hobs, and all is coupled with energy efficiency methods for the building fabric. Will make a big difference to that operational carbon. This is one particular project that's worth taking a look at, with the Dark Matter and Civic Square collaborated on, which is about not just looking at retrofit in terms of the sort of performance of the building itself in isolation, but looking at it as a neighborhood, and both the retrofit of the buildings, but also the public spaces and the amenities, and things like transportation and livability for that neighborhood. So going deep on retrofit, and definitely worth following that project in more detail. And then something that the space that we're doing a lot of work in is around new buildings. This is where we've come to with WikiHouse, is that unfortunately, well, not unfortunately, but we do have a sort of social obligation to build more housing. We can't just stop, and part of that is not just because there's an increasing population, because there's still a large unmet housing need in the UK, and an urgency to get people out of sort of emergency accommodation into a home of their own, some stability. And so when you look at this sort of profile of our total emissions, both embodied carbon embodied carbon for both domestic, which is our particular focus, and then non-domestic. Even just on the domestic side alone, if we were trying to meet this target of 300,000 homes per year that we've had over the last decade, we would essentially blow our carbon budget by 2036, I think it was worked out to be. So there's something that has to change. We obviously just can't keep going the way we've been doing. And even the houses that are going up today or yesterday are going to have to be retrofitted 10, 20 years down the line, because they're just not going to be up to standard to meet the sort performance levels we're talking about, or they're going to be really costly to run. And so there's this, we're still just continuing business as usual, really, at least in the mainstream, and there's a lot that has to change in the space. And one of the things that pushes the focus more and more onto embodied carbon is that the grid itself, the electricity grid in the UK is decarbonising at quite a rate. So we're going to be in a situation where we need to focus a lot on embodied carbon, because that's going to make up the large proportion of the overall sort of lifetime emissions of a building. Because we know that the energy the building is going to be using is going to be more and more renewable based, because of the work that's been done on mostly wind power. And so, yeah, that's both encouraging, but also it's a challenge for embodied emissions. And the way we currently build our homes, we in the UK we have a large proportion which is focused on masonry and cementatious construction. So we've got a lot of concrete and mortar and brickwork in terms of the material profile, and a very little amount that can be renewably grown, or that's biomass in terms of wood and timber. And we sort of need to flip that entirely. So switching from going from carbon emitting legacy masonry construction to something that is bio-based, renewable, and is actually a carbon capture technology, provided you don't just burn it at the end of its life. So I'll get into a bit more detail about that. And we've got this huge opportunity to use what is materials that we need for this construction of these homes to meet the sort of critical housing need that we have as a carbon sink. And we should have started on this yesterday, but this is really the big project of the next few decades. And so what's going to replace brick and cement? I mean, I think the answer is also really obvious, but in some ways there's so many challenges around this. A lot of it is cultural and political. Brick is still sort of desired from a planning perspective, also from an architectural perspective, and that because it's a scale that we're used to seeing in the UK. So how do we sort of bridge that into new materials that also are durable, hard wearing, and have the same sort of aesthetic quality is sort of an interesting challenge. Things like pretty plastic, which is made from recycled UPVC window frames and turned into tiles, is sort of an interesting example. And then more and more, we just need to build with stuff that we can grow, and ideally grow locally, and then mill and turn into housing. So, how are we going to make this process the new normal? How do we go from bricks to something like WikiHouse? And that's our mission. So for those who already don't know, we're trying to develop WikiHouse to be essentially the sort of Lego system for zero carbon construction. It's supposed to be as easy to understand and put together. Anyone can do it. Anyone can understand how it works. There's a lot of engineering design knowledge baked into the system itself, but the blocks themselves are quite simple. And that also means that the process itself is really important. So you can use locally grown forestry timber, can be processed ideally within the UK, and then manufactured ideally as close to site as possible. So your carbon footprint from sort of cradle to gate is as short as possible. And that's sort of exactly the process that we're trying to test through this model of small microfactories, where through the network that we have already, we can sort of demonstrate that there's a potential path to scale, where you have a series of small factories networked together, working in competition but also collaboration, and are resilient and able to produce sort of similar volumes collectively as having one large central multi-million-pound factory that takes years to set up and is really prone to downturns and changes in the housing market. And the big opportunity that lightweight timber construction has is that you can look at different foundation options. So something that we're very passionate about is switching to concrete-free foundations, where you can use things like ground screws or timber piles or something to to be the base frame, base foundations for your building to sit on. The nice thing about these, they can be removed and they can be reused sort of, hopefully infinitely on other projects over their lifetime. So you're not, nothing is single use, or very little. And then sort of just showing the build process, which most of you be familiar with in terms of the assembly of these blocks, and everything can be both assembled but also disassembled in the same way. And that's really important. So when we a couple of years ago, we were fortunate to do some research in depth with Leeds Beckett University, who looked at the life cycle carbon analysis of a typical WikiHouse 2-story project using Skylark, and then did some lifetime modeling in terms of embodied emissions and operational emissions over its lifetime. Diagrams are slightly confusing or interesting, whichever way you look at it, because it's comparing sort of WikiHouse Skylark to an equivalent building built out of brick and block, but with the same performance levels. So essentially the same sort of levels of insulation as the WikiHouse Skylark system. But the interesting thing to note is just on particularly the big difference is the upfront embodied emissions. The end of life, as well, is a question I'm going to sort of delve into next, but is around how do you, this is both based on gross emissions for the waste processing. And so if you need to, what do you do with that waste afterwards? How does it have, is there opportunity for it to have a second life? And if it does get produced into waste, does it become other products afterwards, rather than just being burnt as fuel, which tends to be the sort of option. And so there's some interesting questions then around material reuse. So I did some comparisons here using the data from that Leeds Beckett put together in terms of brick and block versus plywood. You can see just if we didn't reuse any materials at all, WikiHouse would be around sort of close to 9 tons. But if we but compared to brick and block, it's not even close. But then if you start to then do a comparison between plywood with say 40% reuse, you get to the sort of minimum net zero figure that we're looking for. And that's assuming even some material use in the brick and block, which might be maybe the timber roof trusses can be reused, maybe some of the timber beams, maybe window frames, maybe a few other bits of material. And that difference, the 39 tons, is equivalent to driving a petrol car around the world 7 times. So this is just on a single house. So you can start to see the impact that even at a small level you're having by switching to low carbon or sort of carbon positive, so carbon negative building systems in comparison to masonry. And then one of the sort of really interesting recent studies is what's the opportunity with OSB versus ply? That's something we're doing some testing on at the moment, and I'm sure we have more to report in the coming months. But one of the sort of immediate differences is that, at least for the UK context, is that OSB can be grown locally here, or the timber for it, and also locally milled. And that difference in terms of the local transportation, essentially from the factory through to is a difference of about 160, 155 kgs of CO2, and that's enough over the course of the amount of material that we're using to be the equivalent of flying a 747 from Heathrow to Edinburgh per house. So it's definitely measurable and probably quite desirable that we can crack the OSB option. And that means in comparison to the diagram earlier where we had the masonry construction, then we're pushing most of the material into sequester carbon, and what we've got left is a few other elements like insulation, foundations, plasterboard, which is stuff that's got a carbon cost to make, but maybe can be reused, and we need to find processes for doing that. So if we look at WikiHouse in this context is great, but and we've done a lot of these one-off projects. But how do you really scale it? And we need to scale processes like this. It doesn't have to be WikiHouse exactly, but other types of bio-based construction using local materials, using local manufacturer. And how do you sort of scale it up? And one of the ways is that if we've got this sort of large open network of CNC machine shops, we can simultaneously produce all the parts we need for houses across the network. And there's obviously supply chain challenges and sort of overhead challenges in terms of managing this process, but the opportunities are huge because a lot of these workshops have capacity and they already exist, and the machinery and tools are there. What's needed is the sort of infrastructure to link them all together. And one of and just in terms of running some numbers on this was quite interesting. For equivalent of building 20 3-bed homes, there's about 9,000 sheets of OSB, and basically it all comes down to time. If you had a sort of tight deadline for a large site, in under 3 months with 8 CNC machines working across different sites, you could produce 20 homes. And those parts could all come together, be stored flat pack in a sort of central location. And the sort of next evolution of that is that you essentially have a large assembly warehouse, which could be set up as a sort of flying factory. It doesn't have to exist permanently. That can be quite near to site or even on the site if it's a sort of larger scheme. And this is essentially just an assembly workshop where blocks are put together, they're insulated, and they're ready to deliver just in time for constructing each of the units. And so, just sort of working out the sort of space requirements of that and what that looks like has been quite an interesting exercise. And then, so the big picture vision, if we were going to achieve something like 50,000 WikiHouses per year, which would make quite a large dent in the sort of housing need requirements that we have. It's equivalent to sort of say 4.6 million square meters, which is about the total floor area of all detached homes built in the UK a few years ago, just as a reference. But it will take about 28 million sheets of timber, which is quite a lot, as you can appreciate. It's 22% of all European OSB production. A lot, but not impossible. And one of the things will be, this is not something off the bat that we really have to scale, not just the manufacturing capabilities of the building systems, but also the milling capabilities and sawmills and forestry to deliver that. And doing that with 7,000 CNC machines is maybe sort of dreaming, but interesting to dream. And so if we're going to do this, we need to do it in a way where we're not going to screw over everything that we had, and we need to make sure that the forestry that we are growing to produce these biomaterials is done in a sort of regenerative way, and that it's not all about sort of just dominating the landscape with sort of a monoculture of single plantations. So there's a lot of work being done on this by a lot of people much smarter than myself around some management of these forestry systems and how these materials can be sort of linked into other supply chains. There's an interesting case study which you should definitely check out by the Material Cultures in Arup did, which is looking at the circular construction within the context of the northeastern Yorkshire, and they did a lot of comparisons between the sort of commonly used building materials and bio-based materials for both structure, lining, insulation that could be sort of locally grown and farmed and milled and produced, and what would be the sort of carbon impact of that. So that's definitely worth looking at, and it's sense of really interesting opportunities for the future, I think, which is moving away from these sort of large centralized supply chains for raw materials into something which is a bit more much more sort of naturally based and sort of more locally grown. There's a project happening at the moment which we've had a bit of involvement at a distance from is with Wessex Community Assets, where they're looking at how they can sort of combine digital fabrication with this local production of materials, and the output being community housing, Southport community housing that could be scaled. They're doing a lot of work with local hemp production to make hempcrete and hemp-based installations. And then, we it's all good if we can make the materials, but we also need to make sure that they can be reused and we can extend that life as long as possible, and also find sort of second lives for them beyond that. And so for WikiHouse, that could mean something like a parts tracking system where each block can be referenced to an online database, and we can know the origin of its materials, who manufactured it, what its sort of end of life situation is like, and it just means that we've got a complete understanding of the impact that this is having, and whether those materials then get disposed of and how they get disposed of. So when we look at a bit more detail, we essentially with WikiHouse blocks we can pretty much solve a sort of circular structural system. There will be waste and offcuts produced from the manufacturing in terms of sawdust and chippings, things like that, and they obviously they can't be reused in housing, but they could go into other products like chipboard or other panel products, and back to the sawmills. And the blocks themselves, it's about extending that life. And then when you look at some of the other materials, insulation has a sort of large degree of reuse, but the big challenge is some of the other things like seals and tapes, which are small in terms of volume and weight, but obviously very difficult to recycle. And so, there's a few other steps the built environment can cope that has a sort of wide impact on beyond just the sort of direct emissions. And one of them is on transportation and land use. There's a big part of how we plan out our neighborhoods will have a big bearing on the emissions profile of those neighborhoods over its lifetime. And so we very much need to move away from the sort of car dependency into sort of closer knit neighborhoods where there's a range of different transportation options, and encourage things like walking and cycling, and rather than spreading everything out and relying on sort of single passenger vehicles. And then the very unanswered question is about how we're going to pay for it, and who's going to pay for it. I do like this cartoon. What we know is that in terms of the total net worth of all the assets, land has a huge impact on that, as well as other things like buildings infrastructure. Very little of our sort of asset worth in the UK is tied into IP and other products. A lot, very much, all of it is housing in some way, housing and buildings. And through some of the research we've been doing on the Fairhold project, it's just really fascinating to note the sort of values that we talk about in terms of real estate versus other sectors that we place so much emphasis on in terms of access and rights and monopolies. We look so much into data and business, but very much the real estate market is sort of undercover sometimes in terms of understanding the impact. And so we do have a project that's underway called Fairhold, which is about looking at land use and about developing open modular templates for different land lease agreements on a fair basis. And what is termed fair is decided by the residents community who is occupying that land, and very much see it as a creative commons for land and property. So watch the space, and there'll be more details of that coming forward soon. And sort of just to finish, we know that there's a big challenge, but we know that as a collective we can start to tackle that. And for more immediately for WikiHouse, our sort of next actions are to look at the UK is to look at OSB over plywood where possible, to look at the as a microfactory model and the systems for management of waste within that, as well as quality control and durability, etc. and then looking at this product circularity around a material passport or a database for WikiHouse blocks, so they can be referenced and looked up and traced, and then be better at quantifying the benefits of this approach versus other approaches. And a lot of that comes down to understanding the impacts we're having and or can have, and while particularly with embodied carbon and biomaterials, we often talk about this as a sort of upfront cost premium. What does that play out in terms of this lifetime? If you don't have to retrofit it later on, if you don't have to reinvest in other better efficiency later on because you've already been built with that to start with, I think has a big impact to play and something that's not really understood very well. And then opportunities to pilot and test this and go deeper on things like biomaterials all the way through, not just talking about the structure, but other things like linings and claddings and energy systems. And just further reading, if you're interested in this stuff, there's a lot of great information out there, particularly from Letty, who are doing a huge amount of policy work on this. UK Green Bin accounts, of course. Best, who are based in Glasgow, are sort of a living lab for testing and running the sort of innovation. And then a good podcast to listen to if you're sort of interested in what's happening in the space. Thank you. I'll wrap it up there.
Thanks, Clayton. Thanks so much. I have a couple of questions about materials. So the first one is, you've mentioned, obviously this is in a UK context, so you've mentioned things like OSB and hemp. What other materials are you guys looking at? And why is, how do we step up the use of OSB?
Good question. I mean, the use of OSB in some ways, hopefully will, we've got the sort of data we need from that. Gabriella, particularly in our team, has done a huge amount of modelling and looking at OSB versus plywood characteristics. And there's been testing with the help of academics from Strathclyde University and Edinburgh, and more recently we're doing some testing with Imperial College, which will be actually give us a lot of data in terms of how the OSB performs within the WikiHouse system. So I think we're very close to saying, look, it's pretty much the equivalent, right? But the next, and then from that it can just be specified in any WikiHouse project. In terms of the uptake of other materials, I think that we've always been with WikiHouse quite agnostic to materials that use other than structural material, because the structure is sort of it's got so many it's guiding the performance characteristics of how the building works. But for other stuff like cladding and insulation and lining, we've always just given suggestions and sort of examples of what you can do, but often people sort of default to what they know, and I think there's a lot of education, and as well as the need for the supply chains to grow and the economies of scale and price to come down for those products. At the moment, there is a massive premium on it, and if you, it's going to take someone who's really keen to pursue this to that level and pay that extra, knowing that what they're getting is a really healthy, sustainable building. But it's going to take a while before that sort of mass market cost is available for everyone. But the only thing that's helping that direction is that the cost for everything else has gone up as well. So it's not as much of a premium as it used to be, but it still is a difference.
The other thing I was going to ask is, you briefly mentioned the waste when it comes to materials like OSB for when you're cutting patch for a WikiHouse. You said sawdust, for example. What happens to the waste? Actually, we know the waste in construction is a massive issue, but what happens when you're building with WikiHouse, for example, and you have some waste?
At the moment we don't mandate anything. It's been up to the manufacturers to use their own processes for this, and a lot of them have quite good ones. There's companies like Ego who will collect skip loads of scrap timber and turn it into timber panels for like furniture and other construction. West Fraser themselves, who manufacture the OSB panels in Scotland, they'll collect up any offcuts and turn them back into OSB panels. yeah, for the larger pieces, that's sort of the obvious things that they go into other products, or back into remaking the same product. Occasionally, they could be burnt again as a fuel replacement, but that's only going to work for so long. And I generally we should be trying to encourage people not to burn anything. And the sawdust stuff is interesting because it could be used in things like wood fiber or cellulose potentially. It's mostly just collected in big bags from extraction machines. But I have to talk to you'd be able to talk to people like pulp builds and other manufacturers who deal with a lot of this stuff day to day, and what they the sort of things they put in place for that. But we're very keen to see if there's standard solutions that we can say, look, if you manufacturing wiki houses, this is where your waste should be going, because it's the whole life carbon story is not going to stack up if everyone's just disposing or burning of it.
On that note, you had a diagram with the circular diagram. Would you mind sharing it for more than a few seconds so people can look at it?
Sure.
And will you make the slides available? That's another question.
Yes, of course. I can share a link or something in the video if that's useful. To put it on the community page.
We had so much data that I think we just need a little bit more time to look at it properly. That's the one. Yeah, can you tell us a little bit more about that?
I think it'll be easiest if I'll share this diagram afterwards, definitely. But we're just looking at what are the main sort of materials within the WikiHouse house structure, as being the big one, sort of proportionally, and then things like insulation, foundations. Again, if we can use something like the ground screws, which can be completely taken out and reused on other projects. Things like cladding, if again, dry fix is the sort of the approach here for cladding, linings, stuff that can be demounted and taken away, rather than using wet trades where stuff gets broken and then has to be scrapped. And so everything can mostly follows a cycle of recycling, if not reusing. But there are lots of questions here, and it'd be nice to get to the point where we can say, look, let's do a sort of pilot, which is a circular house, and test this and say, okay, look, everything in here can be completely demounted, taken away, reused, and built again, and prove that as an example.
Yeah, wouldn't that be amazing if we could do that? Brilliant. So you're happy to share that. You gave a shout out to some really interesting links on your last slide, I think. So if you could just leave that up for a little bit so people can go. I think you mentioned BEST. You've mentioned the podcast as well. And people can find out about the work of OSL at opensystemslab.io. So if you guys have any questions, please put them at the bottom of the recording. This is being recorded just now, and it will be available in a couple of minutes. So thank you so much, Clayton, for joining us today. We will be back on the 25th of May, as I said, and we're going to be joined by Digital Voodoo, who's WikiHouse manufacturer based in Cumbria, and they'll be telling us about all the work they're doing with WikiHouse in England. So thank you so much, and we'll see you soon. Bye.